start. Okay, so here we are. We're going to do this experiment again, and this time we have 39 lights plus one additional light to make 40. So we're going to increase by 1/39 whenever I step down on the switch here. I step down here, it adds one additional light over there. When I step down on here, we go from 39 lights to 40 lights. And we go from 3005 ohms to 2961 ohms. Now, 2961. So now I'm going to move this closer until that gets to 2961. Oh, there it is. .2961 we're at, and I'm going to step down on this thing now. 2917. Unstep and move it over until it goes to 2917. There it is. And then I'm going to step down again. 2873. Move over here till I get to 2873. That's 2873. Step down again. 2830. Now we're 2830. Step down again. 2788. A little closer till it gets to 2788. And then step down, and we're at 2747. Move it to 2747. Step down. 2707. Two 707. Two 707, and then step down. 2668. And then 2668. And then step down to 2629. I slide this till I get to 2629. And then 2592. $2,592. I'm going to step it down to 2554. And slide this back to 2554. Good. And we're going to step it down to 2517. 2517. And then 2480. And then 2443. And then 2409. Two, 374. And 2340. And 2306. And then 2272. Two 2239, I guess 2239. Two 2207. Two 2174. Two 2144. 2143. Well, 2144. Yeah, that's good. 2144. Two 2113. Two 2081. Two 2051. 2021. $1991. Now we can probably switch the range because we got down to a 1 in the last digit. 1991. One nine nine one, 1985, 1991, and then I need to get it to 19893. 19893.
I'm lost now.
Well, on this range, it's 1992, right?
Mm-hmm.
And when I change it to the next range, it's 19894.
198. What? 198.97. That doesn't make any sense.
That's 0.1992 kiloohms. It's probably actually 1.992 ohms, because remember the last one was 200 ohms?
Right, so those are all Ks, and then this is actual ohms. See it now.
So it's 199.3 ohms, and then when I switch it, it goes to 198. 198.94, which is 199, if I round it off. It's not quite, there's a bit of a discrepancy, isn't there?
Yeah.
So 199.3 ohms, and then when I switch it, it's 198.94 ohms. So I got to step off and go to 198.97 or something.
Okay.
198.97. I got to move it forward until it gets to 198.97.
Okay, that makes sense.
I mean, this is where we could buy a Keithley, I guess,
Hmm.
and be a little bit happier, but this is sort of student grade equipment, right?
I suppose, yeah.
And then I'm going to step down again, and now it's 196.192, 196.2, let's say, 196.2. And then I got to move this till it's 196.2.
I can use alt codes.
Yep, there it is. That's pretty good. And then this is 193.35.
Okay, so 196.20 to 193, 193.35.
35. Yep.
Okay. Timing.
$90.56. 90.56. I gotta move it forward till it gets to 190.56. That's good. Let's step on it again. Now it's 100 and step down 187.8. 187.8. Okay. And then now I'm going to go okay. Step down to 185. And go to 185. that's good. And then now we're coming down to 182.35. Push it over to 182.35. Okay, step it to 179.6. 179, say 179.66 maybe. 179.66, yeah. And then 179 point. Good. And then 176.9. Okay, and then make sure so that should be 176.9. It's roughly. I step it. It goes to 174.35. I could take this down to 174.35. Oh, too far. 74.35, that's good. And then I step it, and it goes to 171.85. And then 71. Yeah, that's good. And then I step it down to 169.3. And take it 169.3, roughly. Okay, and then it's going to come down to 167.05. Okay, and it steps down to 164.65.
Watch your paper.
Oh yeah. What were we looking for? What number do you want?
164.65.
Okay. 162.2. One 159.8. So now we'll move this till it gets to 159.8. Okay. And then it steps down to 157.45. Move it over to 157.45. And then it steps down to 155.2. I need to advance to 155.2. And then 155.2, yeah, that's good. And then steps down to 153. I'm going to move it down to 153. And then the resistance steps down to 150.68. And then I'll move this to 150.68. and then the resistance steps down to 148.5. And then I move it over to 148.5. Okay, and then resistance steps down to 146.4. Move this 146.4, and the resistance steps down to 144.4. What a 2 ohm difference. 144.4, move it down. 144.4. And then the resistance steps down to 142.25. And I move this to 142.25. And the resistance steps down to 140.19. And we put 140.19 on here. And then the resistance steps down to 138.15. $138.15. And then resistance steps down to 136.1. Now we need 136.1 on this. And then it steps down to 134.2. And then okay. And then it steps down to 133.3. Or what? No, 132.3. 132.3. And I need to go 132.3. And then I need to step it down to 130.45. We gotta go 130.45. And then we need to go to 128.7. Go 128.7. And then step it down to 126.9. Drop it to 126.9. And step it down to 125.1. We gotta move it forward until we get to 125.1. And then we'll step down to 123.3. Move forward. .3, and then goes to 121.45. and then get down to 121.45. And then goes to 119.65. I need to go down 119.65. 19. And then steps down to 117.65. Okay, and then steps down to 115.9. 115.9. It's better if my hand's not near it too. It's better if I pull it from back here. 115.9. It's hard to push a rope though.
Freeze it first. 115.9.
Okay, and then 14.3. And then and then 112.7. 112.7. $12.7. Okay, and then step down to 110.06. So I head to 110.06. That's good. And it steps down to 108.55. Move it ahead to 108.55. Steps down to 107.16. 107.16. So now move it ahead to 107.16. And then it steps down to 105.8. Say 105.75. 105.75, I'd say. Seems to settle at 105.75. Okay, then it steps down to 104.31. That steps down to 102.9. 102.9. And 102.9. Goes 102.9 goes to 101.52. And then what were we aiming for? 100 and
I thought it was 101.52.
101.52
Yeah,
is what we want, right?
I thought so.
And then that steps down to 100.16 or 100.16, and then we move that down. Okay, that steps down to 98.79. That steps down to 97.3. 97.4, I guess. 97.4 steps down to 97.4. And then I got to go to 97.4. Okay, and that steps down to 96.15. 96.15. Okay. 96.15. And then that goes down to 95.05. Okay. That goes down to 93.64. That goes down to 92.35. 91.1. And then 99.9. No, 89.9. Right, yeah. No, hold on, it's not doing that anymore. What did it go from to what?
91.1 was the last reading.
Okay. 91.1 is where we want to be, right?
Yeah.
Okay, and then what does that go down to? That goes to 89.95. That goes down to 88.73. And then I want to take this down to 88.73. And then I want to take it down to 87.6. And that goes down to 87.6. And I want to take this down to 87.6. And then it goes down to 86.45. I take it down to 86.45. And it goes down to 85.3. .3 goes down to 84.12. .12, so I'm shooting for, and now I need to see where that goes down to. That goes down to 83, would you say? Yeah. And then 83, need to bring this down to 83. 83 ohms. Is about there. And I'm going to need to step it down and see what it goes. It goes to 81.85. And then now how close can we get before we get errors in, being... Could probably go a couple more, right?
That was about a third of the table ago, no?
Yeah, well, I guess if we get too close to that, it'll be errors because it'll be, coming in at a funny angle. But where are we trying to go now?
81.85.
81.85, so that's 81 point. Five goes down to 80.75. and then 80.75 goes down to 79.7. 79.7 goes down to 78.69, and then 78.69 goes down to 77.65, and then 77.65 goes down to 76.62, and then 76.62 goes down to 75.63, and then 75.63 goes down to 74.6, and then 74.6 goes down to 73.72. 73.72.
Something weird just happened.
Okay, what happened?
73.72. Okay. I was typing and then suddenly I was 3 pages down, and I have no idea how or why. But I'm back.
Where are we trying to get to now?
73.72.
73.72. That's where we are right now. 73.72. And when we step it down, it goes to 72.76. And then when we move this to 72.76 and step it down, we get to 71.83. And then 71.83 yeah, that goes down to 70.92. 70.92 goes down to 70.07. So we're down to less than an ohm now.
Of change, yeah.
I could probably change the range, but that'll probably change the numbers like it did before.
Yeah.
70.07 goes down to 69.21. And then let's go to 69.21. Goes down to 68.35. 68.35 goes down to 67.5. The change is kind of small now, right? 67.5.
Yeah.
So now, if I keep going, it's logarithmic, so we'll never actually get to the end, but the increments are quite small now. And we could do a couple more. We're probably getting close to the limit of useful range. You want to do a couple more, maybe?
Up to you. I can record a few more numbers, but you're the one doing the hard stuff. So.
Yeah. What are we shooting for now?
Oh, sorry. 67.5.
67.5. Okay. There's 67.5 roughly. Now, if I switch to another range, yet another range.
Oh, that is the bottom.
Oh, that is the bottom.
That's as low as it goes.
Okay, 67.5. So we'll step it down to 67.5. 66.68. And then we'll move it till we get to 66.68. And then 65.84. Yeah, that's pretty close to the end of the range. You want to try one?
Oh, I don't want to make a mess of it. 'Cause I'm a different reflectivity than
Yeah,
you
that's
and
true, yeah.
that, so. Interesting.
I'm pretty close to zero reflectivity except for this, I guess. But, yeah. Cool. So in some sense, this is a machine here that could solve differential equations. You know, it's an incremental solver, so we're solving comparametric equations with this machine. Now, with the link between quantum field theory and comparametric equations, perhaps we can build an analog computer that solves comparametric equations, and by analogy, an analog computer that connects us to quantum field theory. So could we build a simple prototype first of an analog computer, you know, with a long linear slide mechanism that's controlled with a servo, and the servo would move this position and quickly hunt and move to the next position. So it would change the light level and quickly move, and change the light level and quickly move. And if we could get it to move quickly, either hook it up to a high precision analog to digital converter, or maybe hook it up to like a Keithley resistance meter that's got a GPIO or something like that, you know, and just swim this whole thing out. That would be super awesome if we could capture and solve these differential equations with a piece of hardware.